video, page 181. Let's go ahead and get started with these problems. Numbers 1 through 5, the directions say to find all of the zeros of the given function. So here we go. Number 1, let's find the zeros, okay? First of all, we have x. Then we have x minus 6 to the second power. So x minus 6, x minus 6. Okay, so what makes this group? What is the 0 for this group here? 0. What's the group for this? What's the 0 for this group here? 6. And what's the 0 for this group here? 6. Okay, so there's the 3 zeros for number 1. Alright, and let me flip to the back of the book so I keep an eye on the answers, and let's continue on. Moving on to number 3. Alright, well, we have x minus 2, and I just looked at the back of the book. They do not need us to write the repeats, so the zeros are 0 and 6, okay? So when we do number 3, there's no need to write x plus 4, x plus 4, x plus 4, okay? You can do that if you want, okay? But it doesn't give you any new zeros, okay? The zeros for each group would be positive 2 for this group, and negative 4 for this group, and of course negative 4 here, and negative 4 here. So there are your 2 zeros. Moving on to number 5. Okay, what makes this group here a 0? Or what's the 0 for this group? Negative 6. What's the group 0 for this group? Negative I. And what's the 0 for this group? Positive I. So the technically correct way to write it would be negative 6 comma plus minus I. Okay, but this is also acceptable. By the way, don't forget, students, please listen. Anytime you have a complex 0 or an imaginary 0, whatever you want to call it, the conjugate will always exist. So if negative I is a 0, you are guaranteed positive I will also be a 0. If one of your zeros is something like 4 plus 3i, then you are guaranteed that 4 minus 3i will also be a 0. Guaranteed. Please don't forget that. Okay, moving on now to numbers 7 and 9. The directions say to use the rational zero test to list all the possible rational zeros, and then verify the zeros shown in the graph are contained in the list. So here we go. First of all, let's go ahead and list all the possible rational zeros. So make sure your function's written in standard form, which it is. Your lead coefficient is 1. All the factors of 1 would be 1 and 1. So we'll just put a 1. All the factors of 3 would be 3 and 1. Okay. Now remember, you take all of these numbers here and you put them on top of the numbers over here. So 3 over 1 is 3. 1 over 1 is 1. And then don't forget your plus and minuses in front of each number. So we have 4 possible rational zeros. They should be over here in the graph. Let's see. Yep, negative 3 is. Check. Negative 1 is. Check. And 1 is. Check. So the only one of these that wasn't used was a positive 3. The rest are all on the graph over here. But remember, when you list out possible rational zeros, you're not saying that all of these rational numbers will be actual zeros or x-intercepts. You're saying that any rational zeros that exist will be found somewhere in that list. Alright, number 9. Okay, it is written in standard form. Your lead coefficient of 2, the factors of 2 would be 2 and 1. The factors of 45 would be 1 times 45. 3 times 15. And 5 times 3. And that should be it. Yes, that's it. So, take each one of these numbers and put them on top of the numbers over here. Alright, and let's see what we come up with. 1 over 2 would be 1/2. I'll put the plus minuses now. 45 over 2 would be 45 over 2. 3 over 2 would be 3/2. 15 over 2 would be, well, 15 over 2. 5 over 2 would be 5/2. And this would not be a 3, what is, students? Sorry, it'd be 5 times 9 is 45. That should be a 9, sorry. And so 9 over 2 would be plus minus 9/2. So there's, so far, 6 of your possible rational zeros. Well, 12 actually, because each fraction has a plus minus in front of it. Now let's put all these numbers over 1. So 1 over 1 would be 1. 45 over 1 would be 45. 3 over 1 would be 3. 15 over 1 would be 15. 5 over 1 would be 5. And 9 over 1 would be 9. So there we go. Now, one of my zeros here, notice your tick marks are in 2. 2, 4, 6, 8. So right here is negative 1 because from here to here's 2. So negative 1 is one of your zeros. Is that on the list? Yes, it is right there. Here we have almost a 2, like 1 and something, I don't know, 1 and a half. That's past 1 and a half, I believe. No, this is 2. That's about 1 and a half because from here to here is 2. This is 4. This is 6. So 1's about right here. That's about 1 and a half. So 1 and a half is right here. 3 over 2 is 1 and a half. This one here is 3 exactly between the 2 and the 4, and that's on our list. And then 5, and 5 is on our list. So there we go. We listed out all the possible rational zeros, and then each rational zero in the graph was in our list. Alright, moving on. Numbers 11 through 19 say to find all the real zeros. All of the real zeros, not the imaginary ones. Now, the first thing I would suggest that you do is try to factor. Always try to factor first. Put a 0 in and try to factor. Pull out what's common and then pull out what's common here. And notice your two parentheses don't match, okay? They do not match, so you cannot factor it. So the next thing we're going to do is we're going to say, okay, no problem. We tried to factor it. Let's put that 0 here so we don't forget there's a 0 there. 0 equals. Now, I would suggest listing out the possible rational zeros, okay? So the possible rational zeros, your lead coefficient is 1, and the factors for 1 would be 1. Your constant term is 6, so the factors would be 1, 6, 2, 3. 1 over 1 is plus minus 1. 6 over 1 is plus minus 6. 2 over 1 is plus minus 2. And 3 over 1 is plus minus 3. Now, notice, students, we don't have any there's no way we can factor it, so we don't have any other hints as to what the zeros would be, except we could try Descartes' rule of signs, okay? So we start here and we go from a positive to a negative is one sign change, then from a negative to a positive another, then a positive to a negative, so we have 3 sign changes. So for positive zeros, now remember that's rational or irrational, don't forget that. We'll have 3 or 1. Now remember, please listen, none of these might work, because what if our zeros are irrational, like square root of 5 or square root of 3 or something like that? So when it says we're going to have 3 or 1 positive zeros, that includes rational or irrational zeros. Now the negatives, possible negative zeros would be, put a negative in there, that gives you a negative term right here. Put a negative in here squared, that's positive, that gives you a negative term here. Put a negative here times that's negative, so it's negative, 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 negative. So what that tells you is there's no negative zeros at all. So all these negative signs, you can get rid of every single one, okay? There will be no negative zeros anywhere, okay? None. So we'll get rid of those, alright? So now we can test these pretty quickly using synthetic division. 1, negative 6, 11, negative 6. I'm just going to try 1 real quick. 1, negative 5, negative 5, 6, multiply 6, 0. Look at that. I found 1 on my first try. So 1 gave me out a 0. So one of my zeros is positive 1. Okay? Now remember, this was an x cubed right here. So now I have an x squared minus 5x plus 6. Okay, so now we're going to use this instead of the longer polynomial function up here. So now we're going to go on to this. So slide this over here, erase all of this, and once you know 1, 0, to be honest with you, life gets really, well, not sometimes really easy, but it sure makes it sometimes a lot easier, because now look guys, we have a lead coefficient of 1. What two numbers multiply together give you 6. One added together give you negative 5. Well, if you multiply multiply these two numbers, you get 6. If you add them, you get negative 5. So x minus 3, x minus 2 is the factorization. So the zeros would be positive 3 for this parentheses and positive 2 for this parentheses. So the zeros are 1, 2, and 3. Alright, moving on to number 13. Okay, we're not going to be able to factor this one, okay, students? So, I'm going to list out my possible rational zeros. I have 1 here. Over here I have 1, 6, 3, and 2. They're the factors of 6. So 1 over 1 is plus minus 1. 6 over 1 is plus minus 6. 3 over 1 is plus minus 3. And 2 over 1 is plus minus 2. So there's my possible rational zeros, okay? Now, look for sign changes real quick, students. So it takes a second. From here to here is 1, and from negative to negative is none. So for my positive zeros, I'm going to have 1, and that's it, 1. You can't subtract 2 from that, so you will have 1 positive 0. Now it might be one of these, it might not be, okay? Now let's put negative signs in quickly for x. Negative x to the third power is negative with a positive sign here. So we have a negative sign. Then put a negative in here, and negative times negative is positive, so we go from a negative to a positive is 1, from a positive to a negative is 2. So for your negative zeros, we're going to have either 2 or 1. No, 2 or 0, okay? So let's just try to quickly test some numbers here, see what we come up with. 1, then 0, then negative 7, then negative 6. We'll try a 1 first. Multiply 1, put it here, combine, multiply, there, multiply. Now I'm getting negative 12, okay? So as long as I didn't make a mistake anywhere, 1 is not one of my zeros. Since I have a 1 here, let's try a negative 1 real quick. That might be it, you never know. So bring down your 1, multiply, negative, combine, negative, multiply, positive, combine, negative. Negative times negative is positive, and thus you get a 0. There we go. So look at that. Okay, so what we're left with then is, this was an x cubed, so we're left with 1x squared minus 1x minus 6. Okay, so there is your leftover function. We know for sure that negative 1 gives us out a 0, so 1, 0. So far as negative 1. Alright, now let's go ahead and factor this. What two numbers when multiplied together give you negative 6, when added together give you a negative 1? I'm thinking of these two numbers here. They give you a negative 6 when you multiply them. They combine to a negative 1. So x minus 3, x plus 2. What's the 0 for this parentheses? 3. What's the 0 for this parentheses? Negative 2. So your zeros are negative 1, 3, and negative 2. Let me check in the back of the book, and that is correct. Negative 2, negative 1, and 3. Number 15. Now, we should always try to factor first. Trust me, factoring will not work. Pull out what's common in these two. Pull out what's common in these two, and you will not get matching parentheses. So, we're going to list out possible rational zeros. There's a 1 here. Here's my 10, so 1 times 10, and 2 times 5. The factors of 1 would be 1, so 1 over 1 is plus minus 1, 10 over 1 is plus minus 10, 2 over 1 plus minus 2, 5 over 1 plus minus 5. Now, students, very quickly, Descartes' rule of signs. There's no sign changes from positive to positive to positive to positive. So students, if there's no sign changes, we know that we have 0. Let's use the word no instead of 0. We have no positive zeros. So I can get rid of all my positive signs, okay? Now the negatives, I'm really not too worried about now. I know there's going to be some negative. I'm pretty sure there'll be some negative zeros somewhere. So I'm going to try a negative, I don't know, let's just make a wild guess here, negative 10. Alright, so here we go. Put a 1 in, and then a 12. Notice we're not missing any terms up top. So if we're not missing any terms, then we write them, the coefficients just like they are. Bring down your first term, multiply, combine, multiply, combine, multiply. Looks like we might get lucky here. Combine, good. So we started off with x cubed. So now we have a 1x squared plus 2x plus 1. So negative 10 is one of my zeros. So z equals negative 10. Alright, so let's pull this out of the way. Let's pull this out of the way. And let's erase all of this. And now let's factor this. It's a trinomial with a lead coefficient of 1. What two numbers would multiply together give you 1? When add together give you 2? Well, this, I would think. If you multiply those two numbers, you get 1. Add them and you get 2. So the factorization would be x plus 1, x plus 1. So what makes this parentheses 0, negative 1, and this one negative 1? So your zeros are negative 10 and negative 1. Okay? Alright, hope this is making sense. Let's continue on to number 17. Alright, if you pulled out what's common, you will not get matching parentheses. Always try to factor first, students, always. But in this case, factoring won't help. So, with that in mind, let's list out our possible rational zeros. The coefficient of 1, that's a factor of 1. Factors of 12, 1, 12, 2, times 6, 3, times 4. So plus minus 1 plus minus 12 plus minus 2 plus minus 6 plus minus 3 and plus minus, I'm not sure where that came from, plus minus 3 and plus minus 4. Okay, now positive zeros. Well, positive to negative, negative to positive, positive to negative, that's 1, 2, 3 sign changes. So there'll be 3 positives, subtract 2, or 1. So 3 positive zeros or 1. Now let's talk about negative zeros. Z, of course, Z stands for zeros. We'll put a negative sign in here. Negative times negative times negative is negative. Put a negative sign in here. Negative is positive times negative is negative. Put a negative sign here. You get a negative and a negative. So all these terms become negative if you put a negative x in. So there are no negative zeros. So just get rid of all the negative signs. They're gone. Alright. Alright, let's go ahead and just pick a zero and let's test it. Or pick one of your possible rational zeros and check it, okay? Let's try, I don't know, 10 worked before. Let's try 12 and see what happens, alright? So we have a 1, a negative 9, a 20, and a negative 12. Bring down your 1, multiply, combine, multiply, combine, and there's no way 12 times 56 gives me some big number. It's not going to cancel with 12, so 12 is not going to work, okay? Well, let's try another number then. I'm not sure what that would be. Let's see here. Let's try, I guess we'll try the number 2, since we have a 1 right here. Get rid of the 1, and we'll try 2. So here we go. Bring down your 1, multiply, 2, combine, negative 7, multiply, negative 5, combine. Did I mess up here? 1, 2, yes, right here would be negative 14, combine, you get 6, multiply 12, and that's a 0. Alright, so you start off with 1x cubed, so this will be 1x squared minus 7x plus 6. Alright. Why'd I do that? Alright, so one of your zeros is 2. So we need to write that down. Zeros is 2. Now let's erase all this. Let's factor this. What two numbers when multiplied together give you 6? When added together give you a negative 7. Negative 6 and negative 1. If you multiply those, you get 6. If you combine them, you get negative 7. So the factorization would be x minus 6, x minus 1. So 6 makes this parentheses 0, and 1 makes this one 0. So your zeros are 2, 1, and 6. Alright? 2, 1, and 6. And let's check that with number 17, and yes, that is correct. Alright, moving on to number 19, our last one here. And here we go. Alright, looks like we have a little more of a challenge this time. We cannot factor this, so it is written in standard form. The factors of 9 are going to be 1, 9, and 3 times 3. For 24, it's going to be 1, 24, 2, 12, 3, 8, 6, 4. Okay? And so I think that should take care of it. Okay? So we take each one of these numbers, put them over these numbers over here. So 1 over 1 is 1, 2 over 1 is 2, so on and so forth. That's not 2, that's 24. This list is going to be really, really long, but we'll quickly write it out. 12 over 1, 3 over 1, 8 over 1, 6 over 1, 4 over 1. Alright, now let's put all these numbers over 9. So 1 over 9, 2 over 9, or 24 over 9, 2 over 9, 12 over 9, which reduces to 4 thirds. 3 over 9, which reduces to 1 third. And 8 over 9, which reduces to 8 ninths. Okay. And then, let's see, 3 over 9, 8 over 9, 6 over 9, which reduces to 2 thirds. And 4 over 9, which is 4 thirds. Alright, now put all these numbers over 3. So 1 over 3 we already have right here. 24 over 3 is 8. We already have that here. 2 over 3 is 2 thirds. We already have 2 thirds here. 12 over 3 is 4. We already have a 4 right here. 3 over 3 is 1. We have a 1 right here already. 8 over 3 is 8 thirds. That's 2 and 2 thirds. I don't think we have that yet. No, we do not. So 8 thirds. And then 6 over 3, which would be 2. We have a 2 already. And then 4 over 3, which is 4 thirds. And we have that already. Now, I'm not going to give you one like this on a test or a quiz. This is ridiculously huge. Okay? So, I'm not a huge fan of problems like this. But, if you were students, to type this into your grapher and get a basic idea of where the zeros are, you would see that one of your zeros should be around negative 2. So let's try a negative 2 and see what happens, okay? We have a 9. Let's see if negative 2 gives us out a 0. Okay, bring that down. That's 9. Multiply. Combine. Multiply. Combine. Multiply. Combine. Negative 2 times 12. Negative 24. Right here, which gives you a 0. Alright, now, we started off with an x to the 4th, so this is x cubed minus 27x minus, or squared, minus 4x plus 12. I really believe this is factorable, so I'm going to go ahead and make a note. One of my zeros is negative 2, because I put a 0 in, I got out. I put a negative 2 in, and I got out a 0. So please don't forget that one of your zeros is negative 2. I'm going to create some space here a little bit to help me with this problem. Now, the reason I say this is factorable is if you pull out what's common in the first two and the last two terms, you have the matching parentheses. 9 goes into both of these, plot at x squared, and you're left with x minus 3. Take the 9x squared, multiply it back through, and you'll get this right here. This is negative, so plot a negative. 4 goes into both of those, and you're left with x minus 3. So write your matching parentheses once. And then your other parentheses will be 9x squared minus 4. Okay? Now, we already found one 0. Don't forget, students, and that 0 was negative 2. Okay? Now, the 0, the number that turns this to a 0 is positive 3. And then here, x squared minus 4 is that equal to 0. Bring the 4 over and make it positive. Divide by 9, you get x squared equals 4 nines. Now, take the square root of this side, that gives you x. Take the square root of this side over here, the square root of 4 is 2, and the square root of 9 is 3. And don't forget your plus minus. Anytime you take the square root, put your plus minus in front of the radical. So your other zeros would be positive, negative 2/3. Alright, let me check that real quick in the back of the book, and yes, that is correct, okay? So there it is, the section on finding zeros by listing out your possible zeros and then finding the real zeros. And moving on, students, to number 21. Numbers 21 through 23 says find all real solutions of the polygon. So we're looking for the solutions. So really it's the same thing all over again. Maybe we can factor this, we'll see. But it's set equal to 0. So pull out what's common over here. C cubed, that's c minus 1. Then over here, we'll pull out a negative 2. And let's see if we're left with c minus 1. I don't think we are. Unfortunately, I wish we were. But we're not. So no, we cannot factor it. So once again, we're doing the exact same thing. We're going to list out the possible rational zeros. There's a 1 here. The factors of 1 will be 1. The factors of 4 will be 1. 4 and 2 times 2. 1 over 1 is plus minus 1. 4 over 1 is plus minus 4. 2 over 1 is plus minus 2. Okay? So there are my possible rational zeros. Okay? Right there. Now, we could try to look at our positive and possible positive zeros and negative zeros using Descartes' rule of signs. I guess I'll try it real quick here. This would be negative, positive, positive, negative. I'm just going to go ahead, since we have such a short list of numbers, I'm just going to plug 1 in and see, hopefully, if I get that right, okay? And try it from that angle. So, I'm going to try 1. We'll try 1. If that doesn't work, we'll try negative 1. So 1, negative 1, negative 2, negative 4. Alright, there's no missing terms, so bring the coefficients down. Multiply 1, combine 0, multiply 0, combine 2, multiply 2. So it did not work. Let's try negative 1 now and see what happens. Bring down your 1, multiply negative 1, combine negative 2, multiply positive 2, combine 0, and that did not work either unless I made a mistake somewhere. Let's see here. 1, negative 1, negative 2, negative 4. Alright, let's continue on. Alright, let's go ahead and try a positive 2. See if that does anything. So here we go. Positive 2. Bring down your 1. Multiply 2. Combine 1. Multiply 2. Combine. Oh, we are missing a term, aren't we, students? Okay. Well, that's okay. Old Mr. Earhart makes this little mistake. Sometimes we're missing a term right here. 4, 3. There's no c squared. So 1, negative 1, 0, negative 2, negative 4. Okay, let's start all over. Let's try positive 1 real quick. Bring your 1 down, multiply, combine, multiply, combine, multiply, combine, multiply, combine. We did not get a 0. Alright, let's try a negative 1 now and see what happens. Bring down your 1, multiply, combine, multiply, combine, multiply, combine, multiply, combine. There we go. So one of your zeros so far is negative 1, okay? So now we're left with this was an x to the 4, so we're left with 1 x cubed minus 2 x squared plus 2x minus 4. Alright, let's go ahead and get rid of this information here. Let's see if we can factor this. Okay, let's pull out what's common in the first 2 and pull out what's common in the last 2. Pull out an x squared and you're left with x minus 2. Pull out a 2 and you're left with x minus 2. Look at that. And here we pulled out an x squared actually. closing parentheses once. Left over the x squared plus 2. Now we know that 2 makes this parentheses a 0. So positive 2. Now, I'm not sure. I've got to look back at the directions. Did they tell us to list out all of the zeros? They said to find all real solutions, okay? Because this is not going to give you a real solution. If you set this equal to 0, you'll have x squared equals negative 2. Take the square root of both sides. X equals plus minus the square root of negative 2, which of course you're going to make that positive and put an I right there. So this 0 here is not a real number, it's imaginary. So the only real zeros are negative 1 and positive 2. Alright, number 23. Once again, we cannot factor this, so list out the factors of 2. That's 1 and 2. List out the factors of 6. 1 times 6, 2 times 3. So 1 over 1, 6 over 1, 2 over 1, 3 over 1. Now, let's go on to 6. 6 over 1 is 6. 6 over 2 is 3. We already got those two, so we're good. Alright. No, my fault. Sorry, guys. We did 1 over 1, 6 over 1, 2 over 1, 3 over 1. Now we're going to do all of these over 2. So 1 over 2 is 1 half. 6 over 2 is 3. We have 3 already. 2 over 2 is 1. We have 1 already. And 3 over 2 is a positive 3 halves. Now, I like to look sometimes and see if Descartes' rule of signs eliminates some of the zeros. So real quick, looking at positive zeros, we have a sign change here, 1 here, 1 here. So positive zeros is going to be 3 or 1. That's not a whole lot of help. Let's put negative y's in for y. Negative y here would be positive. Negative y here would be negative. So there's 1 already. Negative positive, so it'll be positive right here. Negative here. Negative here. Negative here, negative. So there's 1, negative 0, or none. No, 1, it'd be 1, there'll be 1, negative 0, for sure. Alright, so all that we can do, students, is start putting these in one at a time and testing them. I'm going to start off with 1, just because it's the smallest one, so 1, here we go. Alright, so we have 2, and then 7, and then negative 26, and then 23, and then negative 6. So here we go, bring down your 2, multiply, combine, multiply, combine, multiply, combine, multiply, combine. So we did get a 0, okay? So that's good. So we know 1 0 is going to be positive 1. So now I'm left with 2, x to the third. What's a y actually? To be technically correct, 2y to the third plus 9y squared minus 17y plus 6. Alright? And so there's my new trig function I'm going to use. The only problem is I don't think any of these are, I don't think these are factorable at all. Let me look at it again. If you pull out a y squared here, no, you cannot factor this. So we're going to have to use synthetic division again to test some more zeros up here. Now on a test or a quiz, I will make sure that you don't have to test all of these zeros like a list this long. So I'm going to go ahead and erase all this. We know that 1 0 is 1. We know that already. I'm going to go ahead and tell you, just to save time, students, that another 0 for this would be 1 half, okay? So I'm going to put 1 half here. Then we're going to use these coefficients here. So 2, 9, negative 17, and 6. Bring down your 2, multiply, that's a 1. Add, you get a 10. Multiply, that's a 5. Combine, negative 12. Multiply, negative 6. You 2 get a 0. Okay? So it was 2y cubed. So now we have 2y squared plus 10y minus 12. So one of our zeros is 1. And now one of our zeros is, or one of our solutions, 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well, we can factor this. So 1 over 2 is 1 half. Now the question is, can we factor this? Well I don't know. I don't think so, students. Maybe, let's see. We have a lead coefficient of 2. So 2 times negative 12 is negative 24. It's a quadratic trinomial. What two numbers when multiplied together give you negative 24? When added together give you negative 10. Let's think about this for a second. I just don't think it can be factored, students. 6 times 4 is 24, but one's got to be positive, one's got to be negative. 1 times 12, 2 times 6 would not work. 3, 4, 4 times 3 would not work. Let's see, 24. 1 times 24 would not work. 2 times 12. 2 times 12 might work. Yes, it would actually could. So, negative 2, positive 12. Multiply those, you get negative 24. Combine those, you get positive 10. So good, it does work. So very quickly, let's factor this, and let's be done with this, okay? Here we go. 2y squared minus 2y plus 12y minus 12. I picked up the 2 and the 12 and put them right here, alright? So pull out what's common in the first two. That'd be a 2y, and you're left with y minus 1. Pull out what's common here, 12, and you're left with y minus 1. So write your matching parentheses once, and then your other parentheses would be 2y plus 12. Alright? 2y plus 12. So, positive 1 is the 0 for this parentheses. So positive 1, which we knew that already. And then here, set this equal to 0 and solve. You should get negative 6. For this parentheses here, 2y plus 12 equals 0. Bring the 12 over, make it negative, and divide by 2. And let me check the back of the book. And yes, that is the correct answer. Alright, so moving on to number 29. The two directions for 29 say to list the possible rational zeros. Use a graphing utility. Use a grapher to graph so you can get rid of the zeros that don't work, and then determine all the real zeros of f. So that's for 29 and 31. So here we go. First of all, let's list out all the possible rational zeros. For 2, that's 1 and 2. For the factors of 8 will be 1, 8, 2, and 4. So plus minus 1 over 1, 8 over 1, 2 over 1, 4 over 1. Now let's put all these numbers over 2. So 1 over 2 plus minus 1 half. 8 over 2 is 4. We have a 4 already. 2 over 2 is 1. We have a 1 already. And 4 over 2 is 2. We have a 2 already. So there's your possible zeros. Now I'm going to quickly grab my grapher here and clear out my equation I had there. Negative 2 to the 4th power plus 13 x cubed minus 21x squared plus 2x plus 8. And let's hit graph on that, and let's see if we can pick out some of these zeros. Looks like we have a 0, I believe, at positive 1, I believe. So I'm going to try positive 1 real quick and see if that works, okay? So negative 2, positive 13, negative 21, 2, and 8. And bring this down, that's a negative 2, multiply, negative 2, combine, 11, multiply 11, combine, negative 10, multiply negative 10, combine, negative 8, multiply negative 8. So yes, we do get a 0. So we're left with this right here, negative 2, 11, negative 10, negative 8. So it'll be negative 2x cubed plus 11x squared minus 10x minus 8. Alright, so there is your new polynomial function we're going to use right there. And let's get rid of all of this. So now we know one of our zeros so far is 1. So your zeros equal 1. Alright, now looking at the graphing calculator, let's see if we can't find some other zeros here. Let's see, looking at my graph on my calculator, it looks like it goes through 4. 4 looks like there's going to be a 0. Let's try 4. Looks like there's a 0 at 4. So remember now we're using this trig function here. Let's get rid of this one, or not trig, this polynomial function down here is the one that we're using. So I'm going to put a negative 2, and then a positive 11, then a negative 10, then a negative 8. Bring down your polynomial function. Not sure why I keep saying trig function, but anyways, there we go. And we know now that one of our zeros is 4. So 1 and 4. Now students, to be honest with you, I think we're finally done with looking at lists of numbers and experimenting. I think we can factor this. We have a quadratic trinomial with a lead coefficient of 2. I hope we can factor it. Maybe not. I hope so. And it's looking like we might not be able to after all. Let's see. 2 times 2 is 4. What two numbers multiply together give you 4? When add together give you 3. 1 and 4, but they both have to be positive or negative, and 2 and 2. So this is not factorable. Okay. So looking once again at my graph here, it looks like 2 could very well be one of my zeros. Looking at my graph, so I'm going to try 2 real quick. And I think we're going to be good, hopefully. Negative 2, 3, negative 2. Bring this down. Negative 2 multiply negative 4 combine. Negative 1 multiply. Negative 2 is not working. Let's see. Boom. Boom. And I believe that 2 is supposed to work. So I'm not sure what's happening here. Let's see. Maybe I made a mistake back here earlier. I hope that I did not. Alright, let's see here. Negative 2, positive 3. This is a positive 2 right here, isn't it, students? Yep, sure was. Sorry about that. That was a positive 2 right there. And 4 times 2 is 8, so it should be a positive 2. So, alright, takes care of that. Let's go ahead and try. Let's go ahead and test positive 2 one more time. So we'll test positive 2. Using these numbers down here. So negative 2, 3, positive 2. Bring down your negative 2. Multiply negative 4. Combine negative 1. Multiply negative 2. Combine, you get a 0. So you're left with 2x minus 1. Okay? So 2 is one of your zeros. So now if we have 2x minus 1, that's a linear factor, so we're all done. Simply take that and set equal to 0 and solve. And if you do that, you should get a negative 1/2. So there's your 4 zeros for this polynomial function. Let me check the back of the book real quick. And yes, that is correct. Alright, moving on to number 31. Number 31. Now, that's going to be a lot of factors to list out, but we'll do it quickly. The factors of 32 would be 1 times 32, 2 times 16, 3, 4, 4 times 8, 5, 6, 7, 8. That's it. Factors of 3 are 1 and 3. So 1 over 1, 1 over 32, 1 over 2, 1/16, 1 over 4, and 1 over 8. And then 3 over 1, 3 over 32, 3 over 2, 3/16, 3/4, and 3/8. Now, with my graphing calculator, very quickly, I'm going to type this in and see if we can eliminate some of these zeros. 32 x to the 3rd power minus 52x squared plus 17x plus 3. Alright, let's see what we get here. Look at the graph right now. It looks like maybe 1/2 is. Maybe. Alright. So I'm not sure if it's going to be 1/2, 3/4, maybe even 1. Yeah, actually it looks like the graph is going right through 1. So I'm going to try 1 and hope that's correct. So I'm going to put a 1 here, and let's hope we get out a 0 way over here, okay? So 32, and then negative 52. I have my doubts about this. Here we go. Bring down your 32. Multiply 32. Combine negative 20. Multiply negative 20. Combine negative 3. Well, look at that. Multiply negative 3, you get a 0. So we're left with 32x squared minus 20x minus 3. Okay, so that's what we're left with. Let me grab that and pull it out of the way down here while I erase some stuff. So this is the new function now that we're going to be dealing with, okay? Right here. Now I wonder if you could factor this, you know. It's a trinomial with a Lie coefficient of 32. If you take 32 times negative 3, you get negative 96. So we're looking for two numbers. Multiply together, give you negative 96. When add together, give you negative 20. I'm not so sure. That's going to be really easy to do, but I think I might have just found it actually. Yeah, I think I did. I think 4 times 24 is 96. Yeah, it is. Look at that. Make that positive, make that negative. So there we go. When you multiply these, you get negative 96. When you combine those, you get negative 20. So I can factor this very quickly. 32x squared plus 4x minus 24x minus 3. Okay, pull out what's common in the first two. That'd be a 4x. And you're left with x plus. That is incorrect. You are left with 8x plus 1. Now, here pull out negative 3, and you're left with 8x plus 1, okay? And so your matching parentheses is 8x plus 1, and you're left over with 4x minus 3, alright? So, negative 1/8 is the 0 for this parentheses, and positive 3/4 is the 0 for this parentheses. So your zeros would be, now what do we start off with at first? I think we used a 1 maybe. Let me see here. Yes, we used a 1 to start off with, and we did get a 0. So one of your zeros is 1, then your other zero is negative 1/8, then your other 0 is 3/4. So there's your zeros. Alright, 1, negative 1/8, and 3/4. Alright, moving on to number 33. I believe we're still in the same section, or maybe not. Let's see. 31. 33 says 2. 33 and 35 say use the zero root features of a graphing calculator to approximate the zeros. Determine one of the exact zeros and use synthetic division to verify your result. Then factor completely. Okay, sounds pretty simple. We're basically, students, on 33 and 35 doing the exact same thing, only instead of just looking at the grapher, we're then going to use our 0 button and actually find the zeros on the grapher and then go from there. So with that in mind, here we go. Alright, students, so here we go. Instead of listing out the possible rational zeros, let me look at the directions again. They do not tell us to do that, so we do not have to do that. Thankfully, that'll save us a lot of time. So let's type this into our grapher real quick. X to the 4th power minus 3x squared plus 2. Alright, let's hit graph. And now here's how you find the zeros. Students, the graph should look something like this. Now, we have a 0 about right here and 1 about right here, okay? Approximately in there. That's what your graph should look like, okay? Now, having said that, what you want to do to find those zeros is to push second. If you'll look at the trace button, top row of buttons, second from the right trace. Hit second trace, let's calculate. So option number 2 is 0. Scroll down to option 2, and now it says left bound. So make sure you go to the left of one of your zeros. Hit enter, then go to the right of that same 0. Hit enter, then it's going to say, and I think I just messed up there, so I'm going to start over again. Okay, left bound. Make sure you're to the left of the 0. Hit enter. Let's find the negative 0 first on your grapher. So make sure you're to the left of your negative 0. Hit enter, then go to the right of that 0. Hit enter, then hit enter again, and it will tell you the 0 is negative 1. So there you go. So one of the zeros is negative 1. That will help us a lot. So moving very quickly, we have a 1, then a 0, then a negative 3, then a 2. Bring down your 1, multiply, combine, multiply, combine, multiply. And that's supposed to be a 0. Let's see if we made a mistake here. 1, 0. Multiply negative, then positive 1, negative 2, positive 2. Maybe I typed it into my calculator incorrectly. Let's see if I did. Plus 2. No, that's correct. Alright, let's see what's going on here. Bring down your 1, multiply negative 1, combine negative 1, multiply positive 1, combine negative 2, multiply positive 2. That gives you a 4. So negative 1 is not working. Okay, students, I'm back because your teacher is in such a hurry, which I should stop doing. I'm setting a bad example in front of you guys. I didn't put enough zeros in, did I? Alright, 4, 3, 2. There should be a 0 here. Alright, so here we go. Bring down your 1, multiply negative 1, combine negative 1, multiply positive 1, combine negative 2, multiply positive 2, combine 2, multiply negative 2. You get a 0. This is x to the 4th, so we have 1 x cubed minus 1 x squared minus 2x plus 2. So students, to be honest with you, really, we can go ahead and erase this. We know that one of our zeros is negative 1. Alright, so one of my zeros is negative 1. And now let's go ahead, and I believe we can factor this. Pull out what's common in the first two. X squared, that's x minus 1. Pull out what's common in the second two, a negative 2. And that should be x minus 1. Let's see, negative 2x, positive 2. Yes, that is correct. Write your matching parentheses once. And students, we went over how to factor this way back the first week of school, and that's why I go so fast at the factory, okay? You should have this totally mastered by now. Positive 1 is the 0 for this parentheses. And plus minus square root of 2 is the 0 for this parentheses. If you set this parentheses equal to 0, bring the 2 over and make it positive. Take the square root of both sides. You will get that right there for your zeros. Let me check the back of the book very quickly. And, it does say to find the zeros. It says to write it in factored form. Okay, very good. So, hopefully everybody understands to write. It says to write your answer in linear, to write the equation. To factor the equation completely. In other words, to factor into linear factors. So, we have our zeros. So change the sign, x plus 1. Change the sign, x minus 1. Change the sign of the positive, that make it negative. And change the sign of the negative, that would make it positive. So there you go. If you were to multiply all of this together right here, which we're not going to do, relax, you would get this up here. So there you go. We found the zeros, and then we found the linear factors. Number 35. Alright, let's grab our calculators very quickly here, and let's go ahead and type this into our calculator. X to the 5th minus 7x to the 4th plus 10x cubed plus 14x squared minus 24x. Now students, please do notice that we don't have a constant term at the end, so we'll have to put a 0 there when we use synthetic division. But to be honest with you, it looks like one of our zeros when I look at my graph for a 0, so I'm going to use 0 right off the bat, okay? So that's 1, negative 7, 10, 14, negative 24, and then 0. So bring this down, that's a 1, multiply 0, combine, negative 7, multiply 0, combine, it's 10, multiply, you get a 0, combine, that's 14, multiply, you get a 0, combine, negative 24, multiply, you get a 0, which is 0. So now we're left with this right here, 1, x to the 4th, minus 7x cubed, plus 10x squared, plus 14x, minus 24. Alright, so we'll start this here, get rid of this, pull this down here, Now, we cannot quite factor this, so let's look at our graphing calculator for another 0. Another 0 is, it's hard to see, let's see, 1, 2, 3, 4, maybe a 5 I'm thinking. Let me look real quick and see on my graph right here. 4 is a 0, so I'm going to put a 4 right here. We have a 1, negative 7, 10, negative 14, negative 24. Bring down your 1, multiply, combine, multiply, combine, multiply, combine. It's a positive 14, there we go. That'll give you 6, multiply, positive 24, so you do get a 0. It was an x to the 4th, so now we have 1x cubed minus 3x squared minus 2x plus 6, okay? So, we now know that one of our zeros is 4, alright? So we'll put that right here, and now we can factor this last function. It is factorable. It's a 4-term polynomial. Pull out what's common in the first two, which is an x squared, and you're left with x minus 3. Pull out a negative 2, and you're left with x minus 3. Okay, so your matching parentheses is x minus 3, and your other parentheses is x squared minus 2. Once again, like the last time. So positive 3 is the 0 for this parentheses, and plus minus square root of 2 is the 0 for this parentheses. So your zeros would be 3, and then plus minus square root of 2. So that's one thing they want us to do. Then they want us to take these zeros and write out the linear factors of the function. So change the sign of this, x minus 0, and then x minus 4, change the sign of your 4, and then x minus 3, change the sign of your 3, and then x minus square root of 2, and then x plus square root of 2. Let me check the back of the book, make sure that we are heading in the right direction, and it looks like we are. And so there we go. There is the linear factors right there. And there are your zeros right there. Alright, moving on to numbers 37 through, hold on one second while I turn back. Numbers 37 and 41. Find a polynomial function with real coefficients that have these zeros. So we're trying to write a polynomial function, okay? Well, we know one of the zeros is 1, so we're going to put x minus 1. One of the zeros is 5i, so we're going to put x minus 5i. We know one zero is negative 5i, so I'm going to put x plus 5i, okay? Now, always multiply. I call them conjugate parentheses first. Always multiply the conjugate parentheses together first, because terms are going to cancel out and make it a lot easier, okay? So x times x is x squared. X times 5i is 5ix. Negative 5i times x is negative 5ix. And then negative times the positive is negative 25i squared. But we know for I squared we're going to put a negative 1, alright? And we know negative 25 times a negative 1 is a positive 25. And these cancel out. So I'm really left with, bring down your first parentheses, x minus 1 times x squared plus 25. Okay, so let's finish this up. Take your x and multiply it through, x cubed plus 25x. And then take your negative 1 and multiply it through, negative x squared minus 25. Now students, this is totally acceptable. You do not have to write your function in standard form, okay? But if you did write it in standard form, it would be x cubed minus x squared plus 25x minus 25. Let me check that in the back of the book, and we are good. Let's go ahead and move on now to number 41. Alright, now first of all, we know we have one parentheses, x minus 2/3, okay? And we know we have another parentheses, x plus 1. Now, remember, this is called a complex or imaginary zero. Well, if any time one of your complex or imaginary zeros exists, then the conjugate also has to exist. So they totally, on purpose, left out a zero to see if you would catch that, okay? So this is a zero also. So now what I have is x, change the sign of the 3 in the radical. So negative 3 minus square root of 2I. And then change the sign of the 3 and change the sign of the square root, the radical. Okay, now I'm going to quickly multiply my first two parentheses together here. You're going to get x squared minus 2/3 over here, positive 1, negative 2/3. We have positive 1/3 x. Alright, there we go. Now, let's multiply these last two parentheses together. And we would have x squared minus 3x plus x square root of 2I, then negative 3 times x would be negative 3x. Negative 3 times negative 3, positive 9, and then negative 3 times this would be negative 3 square root of 2I, alright? And then negative square root of 2I times x would be negative x square root of 2I, and then negative square root of 2I times negative 3 would be negative 3. No, negative times a negative would be a positive. So positive 3 square root of 2I, and then take negative square root of 2I times positive square root of 2I. Negative times positive is negative. Square root of 2 times square root of 2 is 2. I times I is I squared. Where the I squared is, we're going to put a negative 1. And negative 2 times negative 1 is a positive 2. So this should go right up here. Now we're going to erase a bunch of stuff. Students, negative 3, let's see. This term right here cancels with this term right here. This term here cancels with this term here. Alright, so I'm going to erase all of those to make a little bit of room here. And then we'll try to erase this the best we can. There we go. So it looks like to me, students, we're left with x squared minus 6x, negative 3, negative 3, plus 11. Alright, so there we go. And we'll move that right up here. There we go. And there we go. Alright, now we got a lot of math to do here, but that's okay. Here we go. X squared times x squared is x to the 4th, and then minus 6x cubed, and then plus 11x squared. Alright, so I took my x squared and multiplied it through. Then I have positive 1/3 x cubed, and then negative 2x. 1/3 times 6 is 2, and then 1/3 times 11, positive 11/3 x. And now take your 2/3 and multiply it through. That's negative 2/3 x squared, positive 4x, and then negative 22/3. So I only have one x to the 4th term. We'll cross that off. Then we have a negative 6 x cubed and a positive 1/3. That should leave with a negative 5 2/3. Alright, negative 5 2/3 x cubed. Let me check the back of the book to make sure we're not making a whole lot of mistakes here. Everything looks good. And then we have an x squared here and x squared here. So a positive 11, negative 2/3, that's 10 1/3. So positive 10 1/3 x squared. Are there any other x squares? I think that's it. And then for your x term, we have a 4 and a negative 2, that's 2, plus plus 11 thirds. 11 thirds, of course, is 3 and 2 thirds. So we have 5 and 2 thirds x. So 5 and 2 thirds x minus 22 over 3. Okay, now I think the back of the book multiplied the entire polynomial function by 3, which you can do as long as you do it to the entire equation. And so their answer might be a little different, but nonetheless, it will be pretty much the same. Alright, except for just the fractions being gone. So there we go. There's your polynomial function. Moving on to numbers. To number 45, the directions say to write the polynomial as the product of factors that are irreducible over the rationals, and then as a product of linear and quadratic factors that are irreducible over the reals, and then in completely factored form. Now, that sounds a little confusing. Let's take this step by step by step, okay? First of all, they give you a hint. One factor is this, okay? So, let me get a drink here real quick. If that's truly one of the factors right there, then we're going to divide that into... Let me show you what I'm doing. If I said, I don't know, if I said 6 is a factor of 36, find the other factor, you would take 6, divide it into this, and the other factor would be 6. So then you could rewrite 36 as 6 times 6. Well, that's all I'm doing here. They're telling us, I did not mean to do that, they're telling us that one of the factors up here is this right here. So divide this into the polynomial and find out what the other factor is. Now I would use synthetic division, but you can't use synthetic division for something like this. So x to the 4th minus 4x cubed plus 5x squared minus 2x minus 6. Divide first term into first term. Multiply, that's x to the 4th minus 2 x to the cubed minus 2, let's see here, minus 2x squared. Alright, we're going to change the signs and add negative, positive, positive, negative 2x cubed, positive 7x squared, and here we go. Divide first into first, that gives you a negative 2x. Multiply, that's negative 2x cubed. Negative 2x, positive 4x squared. And then negative 2x times negative 2, positive 4x. So because we have an x term here, bring down your negative 2x. Change your signs and add, it's positive, negative, negative. So, let's see, 7 minus 4 is 3x squared. This is minus 6x. And then here we go. Divide first term into first term. That's a positive 3. 3 times x squared is 3x squared. 3 times negative 2, negative 6x. And 3 times negative 2 is negative 6. Bring down your negative 6. Everything cancels out, which, by the way, it should have be that negative, positive, positive. If this is truly a factor of this, that means it goes in evenly. So now I can say this group here times this group here gives me this original group, okay? So I'm going to erase a lot of this. Give me some room here. And then very carefully, let's pull this out of the way here. So here's one factor. Here's the other factor. So if you multiply those two together, you will get the original problem. Okay, now let me look at the directions. Alright, it says to write the polynomial as the product of factors that are irreducible over the rationals. Okay, so okay, students, I was looking the directions over now. When it says, it's part 1, reduce this so that it's irreducible over the rationals, listen to me carefully. That means you cannot reduce it. You've taken as far as you can and reduced it all the way up to using rational numbers. In other words, you cannot take this any further unless you use irrational numbers. And how do you know that, Mr. Earhart? Well, I'm going to show you. If you try to factor this, it's unfactorable, which means you're going to have to use the quadratic formula. This is unfactorable, okay? So you're going to have to use the quadratic formula. So you have factored this over the irreducible. Let me read exactly how the directions said it. You have factored it irreducible over the rationals. In other words, you cannot reduce. It's irreducible using rational numbers, okay, as far as you can take it. Now next, it says they want it irreducible over real numbers, okay? So, or excuse me, is it real? No, yeah, real numbers. So now what they're saying is they want us to take these as far as we can using just real numbers. Well, if you would please trust me on this, students, because we are in pre-cal. I'm not going to do all the work for you here, but if you were to use the quadratic formula on this, you would get out real numbers. I'm going to show you in a second, okay? And if you were to use the quadratic formula on this, you would not get out real numbers. So listen to me. If we're going to factor this over the set of real numbers, that means we're going to break it down as far as we can using real numbers. Well, you can't break this down using real numbers. Trust me. If you use the quadratic formula to break this down, you will get out imaginary numbers. Trust me. And with this one over here, if you use the quadratic formula on this, I'm not going to take time and do that for you. We're in big pre-cal class, but here's what you would get. You would get -1 plus minus the square root of 3. So I can now break this down into factors like this. X, and then change the sign, so +1, change the sign of the positive, negative square root of 3, and then X, change the sign of the 1, and then change the sign of the negative square root of 3. There we go. So we took this, and we basically factored it, but we factored it using the quadratic formula, because this is a quadratic. So we plugged all this into the quadratic formula, and we got this out for our answer. Then we put it back into the parentheses, okay? Now, over here, let me bring this down. So, part A, here's your answer to part A, right here. Got it? There it is. That's irreducible over the rational numbers. In other words, you've taken as far as you can go with rational numbers. Okay? Now, here's the answer to B. The answer to B is this. Plus, you bring this down beside it because we have broken. It's irreducible when it comes to real numbers. We have taken this thing as far as we can go with real numbers because this can only be broken down using imaginary numbers. Are you sure, Mr. Earhart? Yeah, I'm sure. Because trust me, if you take the quadratic formula and use it on this, you're going to get -1 plus minus the square root of 2i. And if you don't believe me, go ahead and use the quadratic formula. That's what you're going to get. So you cannot factor this using real numbers. So this is the answer to B. It is irreducible over the real numbers. Now C, letter C says to write everything is to factor in linear factors. Okay, no problem. These are both linear factors because X has a power of 1. And so to break this down to linear factors, just use your imaginary zeros. So it would be X, change the sign of the 1, positive, change the sign of the positive, negative square root of 2i, then X, change the sign of the 1, change the sign of the negative, and there we go. Okay, so this is part C because we have completely factored it down into linear factors. How do I know they're linear factors? All of your X's have powers of 1. Those are linear factors. Alright, moving on to number 49. Now let's turn back and look at the book here. For numbers 49 through 53, they give us a 0 to help us find the rest of the zeros. That's kind of a help. So for number 49, they tell us the 0 is 2i. So I'm going to use 2i right here. And then synthetic division. So they're telling me 2i is one of my zeros. Okay. So here we go. And actually, Well, I was thinking of another way to do this, but this is fine. So, we're not missing any terms. So 2, and it's in standard form, -1, 7, -4, -4. So bring down your 2, multiply, that's 4i, combine, -1 plus 4i, multiply, and when you multiply those, I'll do it down here, you get -2i plus 8i squared. I squared is a -1, so 8 times -1 would be -8. Alright, so this times this is -2i minus 8 combine, and you'll get -2i. And I can see now what the problem's going to be. And that's okay, students. I was thinking about doing this a little differently. The problem we're going to have is we're going to be left over with a function that's going to be really weird with a bunch of i's. So there is a faster way. I'm not sure why I didn't do this at first. I should have. If one of your zeros is what? 2i, what they told us. Then remember, what's the other zero that exists? -2i. Remember, if one imaginary zero exists, its conjugate exists. So there's 2 zeros that exist. Got it? So watch this cool idea. X minus 2i. Change the sign. X plus 2i. Change the sign. Multiply those together. X times x is x squared. X times 2i is 2ix. -2i times x, -2ix. And then negative times positive is -4i squared. I squared is -1. So -4 times -1 is a +4. These cancel out, and look what you're left with. X squared plus 4. Now, why'd you do that, Mr. Earhart? I did that because if these two numbers here, if these two imaginary numbers are truly zeros of the function, which they are, then I could multiply them together and get this factor right here, and this should divide into this totally evenly, which will really break this thing down nicely. So 2x to the 4th minus x cubed plus 7x squared minus 4x minus 4. Let me go over that again, okay? Look, listen, students, if your zeros are too high, -2i, then you know for sure that these linear factors exist. They have to. Okay, and if those two linear factors exist, you can multiply them together and get a quadratic factor that will go into this evenly. Okay, so 2x squared, that gives me 2x to the 4th, and then positive 8x squared. Alright, so change the signs. Negative. Bring this down. There's a 0 here. Bring that down. -x cubed minus x squared. So x squared goes into x times. And this would give you a goes into -x times. So -x cubed minus 4x. Alright, so bring this down. Change the signs and add. Cancel. There's a 0 here. -x squared. X squared goes into -x squared, -1 times. -1 times x squared, -x squared. -1 times 4, -4. Bring down your -4. Change the signs, add, and you get a 0. Okay? So, do you see what I've done here? I hope you do, students. Please watch. What I did is this. Basically what I said is this. I'm saying that if you take this group here times this group here, you will get this original function here. Now I can factor this pretty quickly. 2 times -1 is -2. What two numbers multiply together give me -2? When combined give me a -1. Well, -2 and +1. Alright, so 2x squared. I'm going to go fast, guys. We should know how to do this. Plus 1x minus 1. Pull out what's common. 2x. That would be x minus 1. Pull out a 1. X minus 1. So you're left over with x minus 1. 2x plus 1. Then bring down this parentheses here. X squared plus 4. Now we're finished. We know the zeros. The zeros zeros are? Well, you know, for this parentheses, we already know that. We got this parentheses from plus minus 2i. The 0 for this parentheses is 1. The 0 for this parentheses here is negative 1/2. Alright, now let me check the back of the book just to make sure that we're correct on that, but that should be correct. So 49, and yes, that is correct. Alright, moving on to number 53. Now the zeros they give us for 53, or the 0 they give us is 3 plus the square root of 2i, negative 3, plus the square root of 2i. So if that 0 exists right here, then we know this 0 exists also. Negative 3 minus the square root of 2i. So let's quickly put x plus 3 minus square root of 2i. Let's multiply these together and get out a expression we can divide into this. And then x plus 3 plus square root of 2i. So here we go. X squared plus 3x plus x square root of 2i. Alright, positive 3. So positive 3x, positive 9, positive 3 square root of 2i. Now take your negative square root of 2i and multiply it through. Negative square root of 2ix would be negative x square root of 2i. Put it here and they cancel out. Negative square root of 2i times 3 would be negative 3 square root of 2i. So they cancel out. And then negative times the positive is negative. Square root of 2 times 2 is 2. I times I is I squared. I squared is a negative 1. Negative 2 times negative 1 is a positive 2. So we're left with x squared plus 6x plus 11. Alright? I hope that's right. I hope that it is. So if not, we're going to really waste a lot of time here. So let's divide this into our original polynomial. And because we have 3 terms out here, it should go pretty fast. Everything should line up pretty nicely if we haven't made any mistakes, which is a big if, I'm sure. Alright, here we go. X squared, divide first term into first term, that's x to the 4th, plus 6x cubed, plus 11x squared. Alright, change the signs and add, and we get negative 3x cubed minus 16x squared. And so here we go, we'd have a negative 3x, and that would give us a negative 3x cubed. Negative 3x times 6, negative 18x squared. And then negative 33x. So bring down your negative 21x. And make that plus, plus, plus. These cancel. 2x squared plus 12x plus 22. Alright, x squared goes into 2x squared 2 times. 2 times x squared, 2x squared. 2 times 6, 12x. 2 times 11, 22. If you change your signs and add, all of these cancel out. So it worked out well. So we know this group times this group gives me this whole group up here. Alright, so that's good to know. Let's go ahead and get some room here real quick. And let's get this problem wiped out and finished. Alright, here we go. And so students, there's really no need to factor this first expression. We already know the zeros for this expression were, let me look again, I think it was 3 plus minus negative 3. So we know the zeros for this are negative 3 plus minus the square root of 2i. This is factorable here. What two numbers multiply together give you 2 and add to give you negative 3. Multiply those, you get 2, add them, you get negative 3. So x minus 2, x minus 1. So the zeros for this quadratic here was right here, and the zeros for this would be, I should have circled that, the zeros for this would be this right here, Also the zeros for this would be comma 2 and comma 1. So there's your zeros right there. Those are pretty tough. Alright, numbers 57 through 57 through 69, we're going to find all the zeros and then write the polynomial as a product of linear factors, okay? So, we can use whatever tricks we want to use, I guess, from listing our zeros to using a grapher. We have spent so much time during this homework assignment listing out possible rational zeros. I am not going to do that. I'm going to use my grapher, and I will allow you to do the same. So x squared minus 4x plus 1. One of the zeros would be, looks like 0, I think, might be one of the zeros, but maybe not. Nope, looks like we're going to have a fraction of possibly 1/2. Nope, not 1/2, so it looks like this cannot be factored. So the only way to find the zeros for this is going to be use the quadratic formula. So negative b, so negative b plus minus the square root of b squared minus 4ac all over 2a. Alright, and let's save that in case we got to use that again later. And here we go. So negative b is negative 4, so that's 4 plus minus the square root of b squared, that's 16, minus 4ac, 1 times 1 is 1, all over 2a, which would be 2. 4 plus minus the square root of 16 minus 4 is 12, all over 2. And of course 12 is the same thing as 4 times 3. Cross off the 4 and put a 2 right here. So all three of these numbers, 1, 2, 3, are reducible by 2. So this would become a 1, this would become a 1, this would become a 2. So 2 plus minus 1 square root of 3 all over 1. You don't need that 1 there if you don't want it. And you definitely don't need this 1 right here if you don't want it. So there's your zeros. How do I know I'm done? Because what's my degree? Second degree, the most I can have is 2 zeros. And I have 2 zeros right here, 2 zeros right here, 2 plus the square root of 3, 2 minus the square root of 3. Okay, 61, same thing, guys. Either you can factor it or you can't. If you can't factor it, use the quadratic formula. You cannot factor this, okay? There's no two numbers when multiplied together give you 2, and when added together give you a negative 2. By the way, in the last problem, I apologize, the directions also said to write your answer, to write the linear factorization. So the linear factorization would be x minus 2 minus square root of 3, x minus 2 plus square root of 3, okay? Change the sign of the 2 and the positive sign, and then for this parentheses, change the sign of the 2 and the negative sign. Alright, here we go. Well, this cannot be factored, so we're going to use the quadratic formula, and so we're going to go with negative b. B's negative 2, so negative is positive 2, plus minus the square root of b squared, that's 4, minus 4ac, 1 times 2 is 2, and then 2a, 2 times 1 is 2. So next we have 2 plus minus the square root of 4 minus 8 is negative 4, all over 2. Alright, then make this positive and put an I here. Now the square root of 4 is 2, so now I have 2 plus minus 2i all over 2. And of course all of your 2's cancel. So you're left with 1 plus minus 1i all over 1. You do not need to put over 1 if you don't want to. And you do not need the 1 in front of the I if you don't want that either, okay? So your zeros would be 1 plus minus I. Let me check the back of the book to make sure that's correct. And that is correct. So there's your 2 zeros, 1 plus minus I. So now the factorization of that would be, the linear factorization of that would be x. Change the sign of the 1 to a negative. Change the sign of the positive to a negative. Then x. Change the sign of the 1 to negative. Change the sign of the negative to a positive. And there's the linear factorization. Alright, number 65. Now this one here, like I said, I am going to cheat just a little bit and use a grapher, because we have listed out so many rational zeros. We're not going to keep doing that. So x to the third power minus x plus 6. And it looks like one of the zeros would be negative 2. So let's try negative 2 and see if that's one of the zeros. And if so, we should be home free. 1, 0, negative 1, 6. Bring down the 1, multiply, combine, multiply, combine, multiply, and there's your 0, okay? So you're left over with x squared minus 2x plus 3. So there's one of your zeros right here, negative 2. Now, this is not factorable, so we're going to have to use, unfortunately, the quadratic formula, okay? So there it is. And let's pull this up here, and here we go. Negative b will be, so negative 2, that's a positive 2, plus minus the square root of b squared, that would be 4, and then minus 4ac, 1 times 3 is 3, all over 2a, 2 times 1 is 2, so next, 2 plus minus the square root of negative 8, all over 2, okay? Then we'll make this positive, put an I right here, okay? And the square root of 8, we have 2 plus minus 8 breaks down into 4 times 2. Cross off the 4 and put a 2 on the outside. So 2 plus minus 2, square root of 2i all over 2. All three of your outside numbers are reducible by 2. And by the way, if this number was a 3 right here, you could not cancel or reduce these two numbers here. Whatever you reduce by has to go in all three numbers, okay? So this becomes a 1, this becomes a 1, this becomes a 1. So 1 plus minus the square root of 2i all over 1. So there's your zeros. There's your other zeros right there. Let me check the back of the book real quick before we go any further to make sure it's correct. And it looks like it is, okay? So here's your zeros. So you've done the first part of the problem. Next, they want us to write the linear factorization. So change the sign of the 2, x plus 2. Then change the sign of the 1. So x minus 1. Then change the sign of the positive, negative square root of 2i. Then x, change the sign of the 1. Change the sign of the negative. And there we go. Alright, there's your linear factorization. Alright, number 69. Let me make sure we're still in the same section here. Number 69. Yeah, same section, so let's go ahead and use our grapher to help us here. Here we go. Let's type in x to the 4th power minus 4x to the 3rd power plus 8x squared minus 16x plus 16. Let's hit graph on that, get one of our zeros here. Looks like one of our zeros would be a positive 2. And that might be the only one, I'm not sure. So we'll put a positive 2 here, and we'll see what happens. 1, negative 4, 8, negative 16, 16. Bring down your 1, multiply, combine, multiply, combine, multiply, combine, multiply, combine. So we're left with 1x cubed minus 2x squared plus 4x minus 8. So we know 1, 0 for sure is going to be a positive 2. Alright, so let's grab this bracket here and get it out of the way and pull this down and do some erasing here. Now I think this is factorable, students, right here. And so let's see if it is. Pull out what's common, x squared. You're left with x minus 2. And then pull out a positive 4 right here. And you're left with x minus 2. So your matching parentheses is x minus 2. And your other parentheses x squared plus 4. And that was right. The only real zero that's going to show up on your grapher is positive 2. If you were to set positive 2 is the 0 for this parentheses, and we already have that up there, and then the zeros for this, well, think about it. Set it equal to 0. Bring the 4 over and make it a negative 4. Take the square root of both sides. That's plus minus the square root of negative 4. Make that positive and put an I. Then x equals plus minus 2i. So you have positive 2, and then positive 2 2i. Okay, now, or positive negative 2i. Now the only thing is when you go to write your linear factorization, please do remember we had a multiplicity of 2 for the positive 2. So we have the 2 twice. That's very important. If you're going to factor this correctly, you have to have all the zeros listed, including the multiples. Okay, so x minus 2, x minus 2, x minus 2i, and then change the sign of the negative sign here, x plus 2i. So there we go. Not too bad. Okay, moving on to a new section. This next section says, let me flip over, find all of the zeros when there's an extended list of possible rational zeros. Use a graphing to help graph the function. And again, this is really repetitive. And so we'll do these pretty quickly and then move on. We're just going to keep finding all of the real zeros over and over and over. And we're going to use our graphers to help us, okay? There's just no way we're going to list out all of the zeros on these, all the possible rational zeros. So x to the third power plus 24x squared plus 214x plus 740. Let's hit graph and let's see if one of our zeros is close. Looks like we got to change our window to a negative, maybe a negative 15 for the y. Hit graph, and yeah, let's see where we're at here. Looks like one of our zeros is going to be negative 10. Negative 10 is one of our zeros. Okay, you can use the zero finding abilities of your calculator. It's going to be negative 10, and so here we go. 1, 24, 214, 740. Bring down your 1, multiply, combine, multiply, combine, multiply, combine. And so there you go, you're left with 1, x squared plus 14x plus 74. Okay, and so let's grab this real quick here. So we know so far that negative 10 is one of your zeros. And now let's factor this. What two numbers would multiply together give you 74. One add together would give you 14. Alright? Okay, after some quick thinking here, I came up with 4 times. No, would that work or not? Let's see. No, I don't think that would work. So, and for number 73, they want us to find all of the zeros. So what we have to do now is use the quadratic formula on this. And students, I am for doing all of this, but I'm going to be honest with you. Numbers 73, 77, and 81 and also 85 are all identical, doing the same thing over and over and over. So I am going to give you permission to jump on to the last 4 right here, although in your homework all you had to do is numbers 89, I believe, but still I wanted to quickly, I think that's right, yes, 89, but I want to show you how easy this is real quick, guys, how easy this is. If you had a 0 here, 0 equals x cubed minus 1. To find the 0, bring the 1 over, make it positive. Take the cube root of both sides. When you take the cube root, you don't put plus minus. Cube root of 1 is 1, cube root of x cubed is x. So the zeros for this first one here is 1. So you have 1 rational and no irrational. So here it is, 1 rational, no irrational. So that's D. These are pretty quick, okay, students? So real quick, grab the next function, which is x cubed minus 2, and set it equal to 0, and find the zeros, bring the 2 over, make it positive. Take the cube root of both sides. X equals the cube root of 2. Now that's irrational, and you don't put plus minus. So, because it's x cubed, so you have 1 irrational and 0 rational. Alright, so letter A for this one right here. Alright, and then for number 89, set it equal to 0 and solve. X cubed minus x equals 0. Factor out of x, so you're left with x squared minus 1 equals 0. And you can factor this. Actually, let's go ahead and tell you the 0 is the 0 for this group, and plus minus 1 is a 0 for this group. So you have 3 rational zeros and no irrational. Here it has 3 rational, no irrational. Letter B. Alright, and then the last one has to be C, which I'll show you very quickly. X cubed minus 2x equals 0. Factor out of x, x squared minus 2 equals 0. Take this group set equal to 0, you get 0. Take this group here set equal to 0, you get plus minus square root of 2. So you have 1 rational and 2 irrational. 1 rational, 2 irrational. Letter C. There we go. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email. On your